Yes, kindly mute your microphones, everyone. Kindly mute your microphones. Okay, yes, I'm starting the session. Hello? Hello? Yes, I'm starting the session. So, yes, good morning, everyone. So, we are starting with module 2. So, module 2 is about 2D geometric transformations. Module 2 is about 2D geometrical transformations. So in first module, we saw about the basics of how a display devices works. We saw many things about how to write the primitives, how to add the properties to that, right? So writing a primitive, in the sense we learned writing writing the primitives from the basic graphics image, that is from the point. We started writing the primitives, how to write a point. Next we wrote the primitive how to write a line. Next we came up with different types of polygons and all those things, different types of polygons and all those things. Fine. And finally we ended up we ended up our first module with a line drawing algorithm and circle drawing algorithm. So in first module, what we were interested is, we were interested to know how to write the basic primitives and the basic images that we require for graphics. So coming to the second module, so second module is about knowing how to transform those images that we have written in the first module. So in the first module, we have written different types of graphics images. It may be line, it may be point, it may be triangle, it may be house, robot, many things you have seen. So now second module is about, second module is about, so how to perform transformation of those images. So now what do you mean by transformation? First thing, what do you mean by transformation, right? So here basically we will be going with the transformation of, so first we will be going with the transformation of 2D objects, right? So transformation of 2D objects, right? So then we will be going with transformation of 3D objects. So first we shall know what do you mean by transformation. So transformations, these are the operations that are applied to geometrical, right? So these are the, right? So now what is transformation? Transformations are the operations that are applied to geometric description of an object to change its position, orientation or size are called as geometrical transformations, right? So transformations, these are the operations that are applied to the geometrical descriptions of the objects. That means, right, whatever object we write it, right, or whatever object we try to describe it, right, we will try in this in the transformation concept, we will try to apply some operations on that object which we have written, right, so that we can change the position of the object what we have written, or we can change the orientation, or we can change the size of the objects that we have written, right? So basic 2D transformations that are available is, right, translation, rotation and scaling, right? So these are generally visible, these are generally available in all the OpenGL packages. So other two different types of transformation that are available is reflection and shearing, which are available as an extra package in OpenGL, right? So what are these 2D transformations basically? Translation, rotation, scaling, reflection and shearing. So translation means, right, moving the object from one place to another place. Kindly mute it. Okay, so different transformations that are available for the objects that we write are translation, rotation, scaling, and the other two are reflection and shearing. So what do you mean by these five things in brief, right? So in brief, what we mean, yes, in brief, what we mean by these things are, right? So translation is moving an object from one place to another place. So rotation means, right, the object what we have written, trying to rotate that. That means changing the orientation of that. And scaling means the object what we have written, right, we will try to change the size of that object. Fine, that is what we mean by scaling. Then coming to the fourth one, that is reflection. I think everyone knows the reflection, right? Whenever we write the object, we try to see, right, the reflection of the object on different axes. That is, if I write any object, that means if I write a triangle, I will try to see the reflection of the triangle on x-axis. I will try to see the reflection of the triangle on y-axis. I will try to see the reflection of the triangle on z-axis. Then coming to shearing. So what do you mean by shearing is, right, shearing is nothing but changing the angle of the changing the position of the object. Changing the position of the object means, right, you may have seen many apps what you have, right? So you may be having a circular face, right? So that face you may convert that into triangle face. If that face you may convert that into square face. That face you may convert it into different shapes, right? So this is what you mean by shearing, right? So now we will be seeing one by one, right, how translation works. How can I apply translation to my object that I have written? How can I apply rotation to the object that I have written? How can I scale my object that I have written? How to provide reflection and how to provide shearing. So in today's class, we will be seeing first two things: how to provide translation for my object and how to provide rotation for my object. Okay, fine, right? So now coming to the first part, that is coming to the first type of transformation, that is translation, right? So yes, be clear here. I am applying all these transformations, right? So to a 2D object, not to a 3D object. Whenever I say a 2D object, right, it consists of two axes, that is x coordinate and y coordinate for each and every object. Okay, right? So now yes, everyone can yes, I think everyone can see this slide, right? So yes, in this slide, right, so can see this point P and P dash, right? So now what is this P is? P is my actual point, okay, what I have written. So now I need to apply translation to this object, right? What do you mean by this translation to this object? In the sense, right, so I need to move my object P to P dash. Okay, right? That means I need to move my object, right? That is, I need to move my point, right, which is here, to this position. Okay, right? So we will see how to do that, right? So use mathematically. Fine, right? So first type of first type of transformation is translation, right? What is translation? In translation, here we are moving the original point position of an object along a straight line path to its new location. That means, yes, right, that means, right, my point which is here, right, I am moving the original point position, right, along a straight line path to some other distance or to some other coordinate, right? That is what we are trying to do now, right? So now basically how do I do is, right, whenever I say P point, whenever I say point P, it is nothing but it contains the coordinate x coordinate and y coordinate to that. Fine, right? So now if I want to move, right, this is the original coordinates, right? If my original coordinates are P, x comma y, okay, P, x comma y, fine, right? So then if my coordinates or original coordinates are P, x comma y, right, then I need to obtain the new coordinate position P, x dash comma y dash. That is, I need to come to this point. From this point I need to come to this point. That means I need to move my point from this position, that is from this coordinate xy coordinate to this coordinate x dash and y dash coordinate, right? How to do this, right? So it is translation of 2D object. It is very simple, right? So now whenever I talk about okay, right? So now how to translate how to get the new values of x dash and y dash, right? It is simple. It is just calculated as, right, new x dash, that is for my new coordinate P, for my new point P, x coordinate, it is x dash, it is nothing but the old x plus what is the moment called, what is the moment along x axis, and y dash, it is nothing but, right, old y plus what is the moment with respect to y axis. Fine, right? So whenever they ask you the problem with respect to translation, they will give you this x, tx, y and ty, right? And they will ask you to calculate what is the new translated point, that is coordinate x dash and y dash. Fine, right? So that is very clear with this slide, right? Where if I want to move this point from this point to this point, right, that means I need to change x coordinate of this point and y coordinate of this point. What change I need to do with x coordinate and y coordinate of point P so that it comes to P dash, right? It is nothing but old x coordinate plus the moment along x axis tx will give me new, that is x dash, and coming to y dash, that is with respect to y coordinate of P dash, right? How I will be getting the new y coordinate of P dash? It is nothing but old P plus it is ty. That means, right, the moment along, right, the distance, the moment along y axis, right? So if I add x plus tx and y plus ty, I will be getting new what is the P new point P dash, which is nothing but x dash and y dash. Fine, right? That is what they have given you, right? That tx and ty is called as translation vector or shift vector column. Right? Fine. So the vector representation is simple. It is given as this, right? So if my original point P is x, y, right? And if my p dash, that is my new point, is x dash and y dash, right? So what is my translation vector? Translation vector is tx ty. That is how much I need to move along x axis, how much I need to move along y axis, so that I will get the new point p dash, right? So this is nothing but, right, this allows us to write the two-dimensional translation equation in the matrix form, that is this, right? P dash, new p dash is equal to old p plus t, right? So p dash is equal to p plus t, right? That is this form, right? So x dash, y dash, so x dash is equal to tx plus x, y dash is equal to ty plus y, right? That is how I can translate my I can translate a point from one position to another position along the straight line. Keep this in mind, right? So translation means movement of one point from movement of that is the moving one point, right, from one place to another place along the straight line, right? So I cannot go any way curved like this, right? I need to move my point from one place to another place through the straight line only, right? Then I can apply this translation phenomenon, right, to get my new point p dash and x dash, right? And another important thing with respect to translation, right, translation is a rigid body transformation, right, that moves object without deformation, right? Translation, it is a rigid body transformation. Rigid body transformation means whole object will be moved from that place to the new place without any deformation. Without any deformation means, right, the complete object will be moved from one place to another place, right, whenever I use this mathematical formula. Okay, that is what you mean by a rigid body transformation, right? So my translation is a rigid body transformation which moves the whole object from one place to another place. It doesn't work by pixel, it works with respect to coordinates, right? With respect to my object, one any object you take, right, you change the x and y of that object by giving this tx and ty. By adding this tx and ty, you will get new point, right? So p dash, that is x dash and y dash. Fine, right? So a simple problem on this translation, right, which they may ask you, right? So consider a point p which is a 4,7 with the translation vector tx is equal to 2 and ty is equal to 3. Okay, right? So find the new translated point p dash, which is x dash and y dash, right? So according to my phenomenon, what is p dash, right? So p dash is nothing but p plus t. That is, p dash is my new point, right? So my new point is equal to old point plus this translation vector along x axis and y axis, right? That is, my p dash is nothing but x dash and y dash. Fine, right? So what is my x dash, right? X dash is equal to old x plus what is the moment along x axis, y dash is equal to old y plus what is the moment along y axis. Fine. So what they have given, so x is 4 and y is 7, right? And what is the value of tx? Tx is 2 and this ty is 3, right? So what is my new point? X dash is equal to x plus tx, that is 4 plus 2, right? And y dash is equal to y plus ty, that is 7 plus 3. So this, so what is my p dash? X dash and y dash is 6 comma 10, right? So my point which was in 4 comma 7, right, whenever I give the translation vector of with respect to x coordinate 2 and y coordinate 3, what is the new point that I get, right? It is 6 comma 10 by using this particular formulas, where new x dash is equal to x plus tx and new y dash is equal to y plus ty. Fine, right? So this is about the translation of a 2D object. Okay, right? So translation of a 2D object. Fine. So next thing is, right, we will be seeing how to rotate a object from one position to another position. Fine, right? So next concept is 2D rotation, right? How to rotate an object. Fine. A two-dimensional rotation of an object is obtained by repositing the object along the circular path in xy plane. Okay, right? So what do you mean by rotation that we are dealing here, right? So this rotation is about this, right? So I have my point p here, right? So that is an object I have, right? It may, so for explaining, right, it is very simple. So I have taken the I have taken my object as a point. You can take this object as a square, rectangle, anything, right? So basically all these things are made up of points. So you need to apply this translation or rotation for each of the points, so that for example, if you take triangle, triangle consists of 3 points, basically 3 points, right? So whenever you need to rotate a triangle, right, for each of this point you need to apply the rotation formulas, right? And the same thing with respect to translation. If you take a triangle, right, which has 3 points, right? So here I have shown this for a single point, right? How you can translate it, right? On the same lines, if you want to translate a triangle, right? So the triangle will be having 3 points. For all these 3 points, you apply this formula, right? You will be getting new p dash, that is the translated object, translated coordinates of the object. When you plot the translated coordinates of the object, so you will see how it will be, how the object will be moved from one place to another place. Now my second form, my second phenomenon is rotation, right? So in this rotation, what I am interested is, right, see my object p, it is here, right? That is my point p. I need not have to move my point p from here to here. Instead of that, what I need to do is, right, my point p is here. I need to rotate this object from here to here. Okay, this is rotation. Okay, I am rotating, I am not translating it. Translating it means, right, along the straight line, if you change it, if you change the coordinates, that becomes translation. For example, if my point is here, if I want to move my point to here, that is translation. So here my point is here, I am rotating this point to this, I am bringing my point P to this, right? That means I am rotating my point, right? So how can I come to know that whether I am rotating my point or whether I am translating my point? See here, whenever I rotate my point, right? So I find that radius of my original point and the changed point, right, is same. Radius is same. Radius is same means, right, distance is same. There is no change with the distance, right? So change in the distance means that is translation. Fine. So here there is no change in the distance, right? Change is with respect to the angle of my object, right? So how I came to know that the change is with respect to angle of my object, right? See here, radius is same. For my point P, radius is R, and for my point P dash, radius is also R. That means there is no change in translation, that is there is no change in distance, there is change in the angle of my object, right? So this is called as rotation. Whenever I need to change the angle of my object, then that becomes the rotation, right? So now how to rotate this, how to rotate the object from P to P dash, right? That is as simple as that, right? What we have done in the previous translation, right? For example, if my P is of x comma y, I need to get new x dash y dash, right, which is of P dash, right? So now in translation it was very simple. It was just the distance part. So I was just adding x with tx and y with ty. So that was simple, right? So now coming to rotation, right? How to rotate this, right? How to get x dash and y dash. Fine. So now come to this point, right? So this is my point P, right? Which is making an angle of phi. Okay, right? Now on the same lines, come to my P dash, right? So consider this P dash, right, is also making an angle theta. Okay, right? So now consider this angle as theta. Okay, right? So this angle as theta, okay, and this angle as phi, right? So now, right, so how in this figure, right, r is constant distance of the point from the origin, right? That is why this is not translation, this is rotation. Angle phi is the original angular position of the point from the horizontal. That is, this angle phi is the original angle, right? So, and coming to this theta, right? So consider this angle as theta, right? So from this point to this point, it will be theta, right? So this theta, right? So from, and theta is the rotation angle, right? That means my point which is here, right? I need to rotate this point to here, right? That means what is the angle of rotation? My angle of rotation is theta. Okay, right? So before we go further, right, let us first see how can we write x and y, right? What is x, right? So distance from here to here, that is for this point, right? So x and y. X means this is the horizontal distance, right, of my original point, and y means it is the vertical distance of my original point. Is this clear, right? So p of x comma y. What is x? X is the horizontal distance, right, and y is the vertical distance of my point p. Right? Whenever I say horizontal distance, coming to trigonometric concept, this horizontal distance is base, right, and this vertical distance is perpendicular, and this distance is called as hypotenuse. Clear, right? So now how can I write x, right? So for example, right, so if I want this x, right, obviously I need base. If I need base, right, obviously I need to take cos of that phi. Okay, what is cos of phi, right? So cos of phi, anything, it is nothing but base divided by perpendicular, right? Cos of theta, right, that is here cos of phi, right? What is cos of phi, right? So cos of anything is base divided by perpendicular, right? So cos of phi, right, it is base divided by perpendicular, means x divided by r. So x is equal to r cos phi. Okay, right? And on the same lines, right, coming to y. Okay, right, what is this y? Y is r sin phi. What is sin of phi, right? Sin of anything, right, it is perpendicular divided by hypotenuse, right? What is sin of phi? Sin of anything is perpendicular divided by hypotenuse, right? So what is sin phi? Sin phi becomes y divided by r, that is my perpendicular divided by hypotenuse. So y is equal to r sin phi, right? Keep this in mind, right? X is equal to r cos phi, y is equal to r sin phi. Okay, right? So now coming to the whole of this angle, right? What is this whole of this angle, right? So in terms of cos phi and sin phi, right? So it is cos phi plus theta. Coming to sin, it is sin phi plus theta. Okay, right? Fine, right? I'm talking about complete angle, right? What is this complete angle with respect to cos? Cos phi plus theta, sin phi plus theta. Okay, right? So now let us see what is this, right? What is x dash and y dash, right? What is x dash and y dash, right? On the same lines, how we saw, right? So x is equal to r cos phi and y is equal to r sin phi. Okay, how we saw, right? X is equal to r cos phi and x is equal to r cos phi and y is equal to r sin phi. On the same lines, if I take x dash and y dash, that is this one, x dash and y dash, right? What is x dash and y dash, right? So x dash means, right, so it is complete angle, right? So it is complete angle, right, of both of this, right? And coming to y dash is also, right, it is complete angle from here to here, right? So what happens to my x dash and okay, what is x dash? X dash is nothing but r cos phi plus theta, and y dash is nothing but r sin phi plus theta, right? Coming to the previous, as we saw for my original point p, what is x? X is equal to r cos phi, y is equal to r sin phi. So what is x dash and y dash, right? I'm talking about x dash and y dash, right? X dash and y dash means this point, right? So this point means, right, I'm taking the complete angle from this horizontal axis, right? So this becomes phi, and if this angle is theta, this becomes phi plus theta, right? So what is my x dash? R cos phi plus theta. What is my y dash? R sin phi plus theta. Okay, right? So r cos phi plus theta, r sin phi plus theta, right? So this we will expand based on this cos a plus cos a plus b, and this on sin a plus b, right? What is cos a plus b, right? Cos a plus b is cos a cos b minus sin a sin b, right? Cos a plus b, right? It is cos a cos b minus sin a sin b. On the same lines, right? What is sin a plus b? So it is cos a sin b plus sin a cos b. Okay, right? So this is how I will expand my x dash and y dash. Obviously I need x dash and y dash, right? I need this point x dash and y dash, right, to know what is the rotation from p to p dash, right? So what is the equation that I gave for x dash, and what is the equation that I am giving for y dash, right? So based on this, right, what I gave for p, x and y, right, x is equal to r cos phi and y is equal to r sin phi, right? Because cos phi is x divided by r and sin phi is y divided by r, right? On the same lines, I am giving x dash is equal to r cos phi plus theta, y dash is equal to r sin phi plus theta, right? In translation, you can remember, right? What is x dash? X dash is nothing but x plus tx. Y dash is equal to y plus ty, right? So now coming to rotation, it is slightly complex, right? X dash is equal to r cos phi plus theta. Y dash is equal to r sin phi plus theta, right? Which is nothing but r cos phi cos theta minus r sin phi sin theta, right? Y dash is equal to r cos phi sin theta plus r phi cos theta. Right? Now substituting the expression for x and y in the equations x dash and y dash, we get, right, what is x dash? So x dash is equal to r cos theta, because, right, so x dash is equal to x cos theta minus y sin theta, x cos theta, right? X means, right, it is r cos phi, right? So yes, correct, right? So what is x, right? So x is r cos phi and y is r sin phi. Substituting x and y, right? So for r cos phi and r sin phi, right, what is the equation that I get, right? It is x cos theta minus y sin theta, and y dash is x sin theta plus y cos theta, right? That means for new x dash and y dash, right, if I know what is old x and old y, and if they give what is the angle of rotation that I need to do for that x and y coordinate, I can easily get x dash and y dash. Okay, right? So this is one problem that they will be asking you, right? They will be giving you x and y coordinate, and they will be giving you theta, right? That is angle, fine, right? So whenever they give you x and y and theta, right, you need to find the rotation, right? So that means you need to find new x dash and y dash using this formula. Okay, fine, right? So now that means, right, we can write this rotation equation in the matrix form, right? So what is the general equation? P dash. P dash is nothing but x dash y dash. P dash is equal to r into p. That means, right, see here, x dash y dash, it is equal to cos theta minus sin theta cos theta into xy, right? If you do this, you will get the same thing, right? For example, what I need to get, x dash is equal to x cos theta minus y sin theta. So, right, so x dash is equal to, how will you multiply this, right? So x cos theta into x minus sin theta into y, right? So that you will get it. Next, y dash, right? So how will you get y dash? Y dash is equal to, right, sin theta into x plus cos theta into y, right? So that is my x dash y dash is equal to, right, I can write this cos theta and cos theta, right, into x y, right? So that means x dash y dash, I can represent this as p dash is equal to, right, this x and y are my p, right? So x dash y dash is equal to x y, right, into this cos theta sin theta and minus sin theta cos theta, fine, right? So that means, right, so what is my rotation matrix? My rotation matrix is this cos theta minus sin theta cos theta, right? So that is my p dash is equal to r into p. That means, right, if I want to get my new x dash and y dash, what I need to do, I need to take my old x and y and I need to multiply that with my rotation matrix. What is my rotation matrix? This is my rotation matrix. Okay, right? So this is about rotation, right? So for rotation or translation, what I am interested, right? I am interested, right? If any point is given, right, I need to find, if any point is given x, y, right? In translation, I need to find my distance point, right? X dash and y dash. In rotation, right, I need to find my new point p, x and y, where it has my point, my object has changed by angle, right? And not by distance. Okay, right? So our major aim, right, translation rotation. What is the translation rotation, right? So it is to check, it is to get my new p dash, that is my new vertex or point, that is x dash and y dash, right? In translation, how do I get this x dash and y dash, right? In translation, x dash and y dash is x plus tx and y dash is y plus ty, right? Given x, y, and what is the translation vector tx and ty, right? Now coming into rotation, right? So in rotation, right, how do I get x dash and y dash, right? X dash is nothing but r cos theta minus y sin theta, and y dash is x sin theta plus y cos theta, which we can represent like this, right? Where x dash and y dash is p dash is equal to r. R means, right, it is the rotation matrix into my p, right? So this entire equation that I have written, I can substitute this, or I can reframe my equation like this, right? Where x dash y dash is equal to cos theta minus sin theta cos theta into x y, right? This gives me, right, the same equation, these two, right? So I can write my I can write my rotation, right, equation in this form: p dash is equal to r into p, right? Now coming to the same thing with respect to translation, right? How we have written the translation equation: p dash is equal to p plus t. Okay, because this is with respect to distance, I'm changing the distance, right? So it is addition of the distances to my coordinates x and y, right? So coming into rotation, right, what is the rotation equation? P dash is equal to r into p. That means to my old point, right, I'm multiplying my rotation matrix, right? Please keep this in mind, right? This rotation matrix, we'll be using this rotation matrix also in lab set programs, right? Where for my point, right, if you multiply this with this rotation matrix, I will be getting, right, the new point p dash, right, which is nothing but, right, the rotated point with respect to this thetas. Okay, fine, right? So now what I have discussed till now is, right, whenever I rotate my point, right, p to p dash with respect to origin, okay, right, with respect to origin, right? So okay, before that, right, what is the axis of rotation is, right, I am rotating my object, right, from here to here means, right, I am rotating my object anti-clockwise. You can see here anti-clockwise, I am rotating my object anti-clockwise, right? Whenever I rotate my object anti-clockwise, right, so how do I get new x dash and y dash, right? My new x dash and y dash is, right, this equation, okay, right? This rotation matrix is this, okay, right? The same thing, right? So if my rotation is clockwise, right, that means my point p is here, right? I need to draw a new point somewhere here, somewhere here, okay, right? Okay, fine. My point is here. Now I need to draw my new point somewhere here, right? This is clockwise rotation. Okay, right? So what we have discussed is, we have discussed anti-clockwise rotation. We have not discussed how to rotate the object clockwise. Okay, right? So how to rotate the object in clockwise direction, right? So what is about tomorrow's discussion? Tomorrow's discussion is about how to rotate the object in clockwise direction, right? So in clockwise direction in the sense, right? So if my p is here, right, if my p dash is towards somewhere here, that is, if the object has rotated in clockwise, right, what happens to my rotation matrix, right? And the next point what we will be discussing tomorrow is, right, what I am dealing is, I am dealing with respect to rotation from origin. Okay, right. So for example, if I need to rotate my objects from some arbitrary point, right, how to rotate this? That is this example. Fine, right? So I'm not rotating from origin. If my rotation point is somewhere other than the origin, right? How to rotate the object, right? So my rotation depends on two things, right? One is the angle of rotation and the axis of rotation. Okay, right? Angle of rotation, it may be clockwise, sorry, it may be anti-clockwise. Angle of rotation, right, it may be anti-clockwise or clockwise, right? What we have discussed is anti-clockwise, and 95% of the times they ask you the problems based on anti-clockwise direction only, right? Whenever they ask you the problems with respect to rotation, you should first see that, right, whether they have given rotation with respect to clockwise rotation or anti-clockwise rotation, right? So this is what we have discussed with respect to anti-clockwise rotation, right? So tomorrow we will discuss about how to rotate an object clockwise, in clockwise direction, right? What changes happens to my rotation matrix when I rotate the object with respect to clockwise direction, right? And how to rotate an object not from the origin, from any fixed point. Okay, right? If I try to rotate my object from any fixed point, right, how the rotation will takes place. Okay, right? And tomorrow we'll discuss about scaling, right, and reflection and shearing if the time permits. Fine, right? So this is about today's class. Okay, right? This is about today's class, right? Stay logged in, right? Next session will start in few minutes. Fine. Thank you.